Okay, so this is question number 6. A company plans to extract oil from an oil field. The daily volume of oil, V, measured in barrels that the company will extract from this oil field, depends upon the time T is after the start of drilling. The company decides to use a model to estimate the daily volume of oil that will be extracted. The model includes the following assumptions. The initial daily volume of oil extracted from the oil field will be 16,000 barrels. Highlighted. The daily volume of oil that will be extracted exactly 4 years after the start of drilling will be 9,000 barrels. The daily volume of oil will decrease over time, and the diagram shows possible values. So we've got those there. Might need those. So part A, part 1. Use model A to estimate the daily volume of oil that will be extracted exactly 3 years after the start of drilling. Right. So what I've highlighted there will be quite useful to us because we know 2 points. We know the 0 and 16,000, and we know the 4 and 9,000, don't we? Brilliant. We need the gradient between the two, so I think I'm going to put the 16,000 on the top. So let's do that. So we've got 16,000. So I've got to take the 9,000 now because I'm doing those first. And as I'm doing that, I'll be putting 0 minus 4. Kind of looks about right because it's looking like a negative straight line. So the gradient is minus 1750. Doing that on your calculator. Make sure you've got a calculator, of course. So V will be equal to minus 1750t, and the y-intercept is 0, 16,000, so I have to add the 16,000. So what do we want here? We want after 3 years, so minus 1750 times 3 plus 16,000. Let's do that. Calculator. And I get 10,750 barrels. Okay, that is A part 1. Part 2. Write down a limitation of using model A. Right. So the limitation then, well, if we have a look on the t-axis here, if you have a look on the t-axis, if you put that equation that we had equal to 0, and you solve that, you get that t is 64 over 7. So, model A is suggesting when t is greater than 64 over 7, the volume is negative. You could say as V is the volume of oil, it can't be negative. And so unrealistic. Okay, something along those lines. We'll see what the mark scheme says in a minute. Part B, part 1. Using an exponential model and the information given in the question, find a possible equation for model B. Okay, so part B. Let's get my calculator again. So we know from our work with exponentials and logarithms that ae to the kt is the form that we use all the time. Okay, without a doubt. So we have the 16,000 will be equal to ae to the k multiplied by 0. Okay, which will be equal to a. Now, subbing in the point that we've got on the line, we've got 9,000 will be equal to 16,000 times e to the 4k. So 9 over 16 will be equal to e to the 4k. So 4k will be equal to the natural logarithm of 9 over 16. So k will be equal to 1/4 log 9/16. Okay, therefore we got v is equal to 16,000 times e to the power of 1/4 log of 9 over 16. Okay, times by t. After 3 years, so sugar page along, e to the 1/4 log of 9/16. But this time we want 3 years, so I have to multiply that by the 3 that's in the question. Do that. Make sure you got your calculator. And you get 10,392 barrels per day to the nearest barrel. Okay, something to question that, and it's only worth 7 marks. So, if we have a look back at the question, we answered everything, and that is how you can get the full 7 marks for question number 6.